Working with async tasks in C# is both easy and complex at the same time. But now there's a new type that you should at least understand called ValueTask. In this video, I'm going to show you what ValueTask is and how it compares to the regular task, and then we'll discuss when to use each in your code as well as the best practices. Now, software developers should approach almost every problem with "it depends." But in order to do that, you need to first understand what your options are and then what the trade-offs are going to be. That's just one of the reasons why having a great foundation in software development is so critical, even in light of AI. And that's why I provide detailed real-world training every Monday in C# and the related technologies, as well as developer advice every Thursday. Now, if you want to increase your skills and make yourself even more valuable to an employer, I offer paid training at IamTimCorey.com. That paid training funds the free training like this so that everyone can have a great education in C#, not just those who can afford it. All right, let's talk about how tasks work to begin with. So in our C# code, we create a variable. We say this is going to be the task, right? So if you have an async method, it returns a task or a task of type T. And so that task gets allocated onto the stack 8 bytes. That 8 bytes is just a pointer. So if you're not familiar with stack and the heap, I actually have a course on my site called 100 Interview Training Questions. And this is one of them because this is one of those things where it's both theoretical and really practical to understand the difference. So in basic terms, this is way basic, but basically the stack is information that gets allocated just inside the method you're running. When the method is over, that data gets blown away. It's super easy, it's super fast, and it's super cheap to create because when the method is done, the compiler knows, okay, I can, or .NET knows that, okay, I can just delete all that memory usage. That's the stack. Now, the heap is something different. In object-oriented programming, when we create an instance of an object, we're not creating we have that pointer basically that passes around. It's not a pointer, but it's kind of like that, where we pass around and say, okay, this is my person instance. Well, that instance isn't what's actually getting passed around. You're passing around the 8-bit address for where it's located in the heap. Okay. The problem is, and it's not a problem, but it's more expensive to do this because in the heap, well, this memory lasts beyond this stack. So you can have two different methods that both have an 8-bit or 8-byte pointer that points to the location in the heap. That means the data in the heap has to live longer than the methods. And so what happens is the data in the heap, well, at some point it gets bigger and bigger and bigger, and that's where your memory usage gets chewed up. And so we have a thing called a garbage collector. And if you're ever trying to adjust the garbage collector, stop. Don't do that. Let it do its thing. But what it's going to do is say, okay, we have some memory pressure. We need to reduce the pressure. And what it does is it looks for things in the heap that are no longer referenced anywhere in any stack. And it says, okay, I can get rid of these things. They're no longer needed anywhere. I can delete them off the heap. But that takes resources, which is why, if at all possible, we like to put things in the stack. So integers and doubles and those things like that always go in the stack. And so they're very easy. They go away, right? And so, but the downside of that is that if you pass an integer from method to method to method, you're making copies of that, which means that the data that costs for that integer goes in the stack multiple times. Now, the stack is very cheap. So that's a high-level overview, right? So a task, when we have a task, which is whenever you are calling an async method, you're going to have a task. You get an 8-byte entry in the stack that points to a location in the heap. Now, in the heap, it's about 80 bytes. It depends on the task, if it's a task or a task of type T. And then what it does is it holds a bunch of different information, like is that task complete? And here's the output or results from this task. And here's, did it succeed or not? And all that information. It's very efficient, but it creates an entry in the heap for every task. Now, the output is separate from that. So if you're going to return a list of T, and so you wrap that in a task, if it's async, then you're going to have that output be in a separate place, probably in the heap, compared to the actual task information. And then, of course, the stack has that reference to the heap for the task and then the output. Okay, so that's how a task works in general. I know it's kind of nerdy. It's kind of, do I care about this stuff? Usually not too much. But just so you know, every time you create a task, some stuff goes in the heap, and that can put some memory pressures on things if you're doing a lot of work. And this is where ValueTask comes in. Because ValueTask says, hey, what if we didn't have to put something in the heap? And so what they did was they created the ValueTask. Now, the ValueTask in the stack, instead of being an 8-byte pointer, it's actually about 24 bytes. And this lives in the stack. The ValueTask entry, the variable, lives in the stack. What's the benefit there? Well, there is no allocation on the heap. So if you create a ValueTask, there's no allocation on the heap. It's just in the stack. And again, the stack is very, very cheap. And then, of course, just to be very clear, the output here is the same. So it's not like you're saving anything in the output. What you're saving is this heap allocation right here. There's no heap allocation in theory for a ValueTask. Now, let's get into how these two work and why, because the first question you're going to ask is, well, why wouldn't I always use a ValueTask? And the answer is actually, you probably almost always want to use a task, not a ValueTask, but there is a time and a place for this. The basic answer is that you should be always using task. However, when you find that your app has some memory issues and you're finding that usually the result of the return from that async method is actually synchronous. Remember, when you do an async call, use a task, that does not mean that your method is actually doing async work. It may do synchronous work and just return it wrapped in a task. So if you were mostly returning information synchronously, then you may get some value out of doing a ValueTask instead. Because what happens is if all the synchronous work avoids entirely this heap for a ValueTask, but when it needs to, it can do asynchronous work too. And in that case, it will wrap it, it'll actually call a task behind the scenes. So there's some tweaks here. We're going to see what this all means. Yes, this is all theoretical right now. I want to make it concrete with some code, but I want to kind of give you a high-level overview of the differences between the two. So a task is whatever you want to do asynchronously. A ValueTask is reserved for, it makes the most sense for whenever you are returning information that is mostly synchronous calls. You might say, well, why would I ever have a method that's async return synchronous stuff? Well, we're going to see in our example a really common way that ValueTask is beneficial is if you're asking for data from a cache. Because that cache data is probably synchronous. It's right there. And so you don't have to go out to the API or out to the database to get new data very often. You're going to the cache. Well, the cache is going to be a synchronous call almost always. Now, if you have a cache somewhere else, maybe it's not. But if your cache is local, then you're going to be making a synchronous call behind the scenes. And more often than not, hopefully, 99% plus of your calls will be then synchronous to that cache, which means you will save a bunch of heap storage, which causes bloat, causes memory issues. You'll save a bunch of that by using ValueTask. There are downsides. We're going to look at those. But let's go over to the code. Now, I've already started writing some code here. This is a console application in .NET 10. And what I've done is In the program.cs, I just set up a benchmark with benchmark.net to run this cache benchmark. And the cache benchmark's not filled in yet, but basically we've got some setup that's empty, and then we have two methods. We're going to have a task example, which is not implemented yet, and we're going to have a value task example, also not implemented yet. So that's the comparison we'll do, and we'll just see where we see the benefits of one versus the other. Now, to do this, I have tried as much as possible to get everything else out of the way. Because when you're doing benchmarks, if you're not careful, what you're actually benchmarking is, say, the API call as opposed to the task versus value task, which is why what I did was we have this person record here, first name and last name, that's all it is. And for the people data access, it's just going to create a list with 3 entries in it, the same 3 entries every time, and return it. Now, I did put in here the await task.yield. Okay, this is used to ensure that it's truly an async call. So I want to make sure that that's pointed out, because normally what you do here is you would call out to an API or something else, and that would be truly an async call. But because I'm just doing sample code, if we're not careful, that would mess the benchmark up because it's actually synchronous. But we're truly saying task.yield, which makes sure it's asynchronous every time we call this. So that's why it's marked as async, and that's what we'll use for making our calls. So that's the sample or setup code. By the way, if you want the result of all of this code, you can download that down in the description. There's a link to get an email to download this source code. Okay, so let's work on creating our example. So what we're going to do is we'll create a new Control-Shift-A and a new class. We'll call this task example. We're going to try to keep this as very close as possible to the same thing, task versus value task. So what we're going to do is we're going to create a method in here that is going to read from a cache. So first off, I want to, let's do a constructor. And in here, I want a time span. Just so I don't have to hard code it. And we're going to say cache lifetime. So caches have a lifetime, and at some point they reset. So let's make sure we have one for this. So private read only, time span, and this is the cache lifetime. And then we'll say cache lifetime equals cache lifetime, like so. And that's going to be our constructor. And what we're going to do is we're going to, let's add a couple more variables up here while we're here. Private list of person record. And we'll call this, let's make it nullable and call it cache. And then private date time is going to be cache last refreshed time. So this is the last time the cache refreshed. So note that, 1 second. And so we're going to say, okay, is it 1 second past this time? And if so, then refresh the cache. Okay, so now let's create a method down here. We'll call it private async task of type list of type person record. And this will be called load people. And what we're going to do is say cache equals await people data access dot get people async. So remember that's people data access right here? That's what we're calling in this method. So we're going to put that data into the cache. And then we're going to say cache last time refreshed equals date time dot UTC now. And then return the cache as well, because we're saying, hey, here's the cache, the new data, this is an async call. This is always going to be an async call. This is just setup work. So now we have a way to load or update the cache. Now let's create our get people task. So public task list of person record. And we're going to say get people task. And here, what we're going to do is normally we're hoping that we hit the cache. So we're going to say if cache is not null and date time dot UTC now minus cache last refresh time is less than cache lifetime. So as long as we're within that, whatever the lifespan is, let's say we do 1 minute. So if we do 1 minute, which we're going to do shorten that for our benchmark, but if we do 1 minute, then as long as the time now minus the cache last refresh time is less than a minute, then we're going to go to the cache and use the cache data. So that would be return task.fromResult cache. So here all we're doing is wrapping the cache in a task.fromResult because we're not doing an async call here. We are accessing the cache. So we're just returning the data, but when you have an async method, then you have to make sure that, let's mark this async. When you have an async method, then you have to have a task or task of type T. So we have to wrap this cache in a task in order to return it. Now, if that's not the case, we return load people. Okay, so, whoops, we don't have to mark this as async, sorry. We don't have to mark this as async, but you're not actually doing any awaits here. We're just returning the results. So we're returning this async for load people. And what this will do is we can await that call then and get the cache data out of it. So this is a normal way to access a cache is we say, hey, if the cache is available and it's not expired, then go ahead and return that cache data. Otherwise, refresh the cache right there, and then make sure you say the cache has been refreshed as of now, and then return that cache data, the new cache data. So this is a normal way to do a task, to do an asynchronous call. And this is what you need to do by default, is have a task, and then we can await that. Now we'll do that in the cache benchmark, where in here for our task example, actually we should probably bring in, we should probably instantiate these up here and say private task example, make it nullable and say underscore task example. And then in our setup, we'll say task example equals new, and then pass in time span from seconds and say 1. So it's a 1 second cache timeout, really short. But that means that down here, we can say task example dot get people task, like so, and then we'll actually return await this. And we should also mark this as yes, this is not going to be null. Okay, so a couple things to note here. First of all, I use the exclamation point here because this is marked as nullable because we first instantiate the class, it will be null. But in the setup, we make sure we instantiate, therefore it will not be null when we get here. We're returning an await of this, which means it will return the actual data. Okay, so this for us is going to run the task example. So it's going to say, hey, let's get the people task, which get the people task is going to either return from the cache or it's going to load the cache up and then return the value. So again, this is normal stuff. This is normal way of accessing cache and doing asynchronous work. However, what we want to do is we want to switch over to a value task. So what I'm going to do is I'm actually going to copy all this task stuff, but not the actual task example. So copy all the contents of the class, and Control-Shift-A and say value task example. And we'll get rid of the using directives. And I'm going to paste in, well, let's make it public first. I'll paste in the contents of what was a task example. Notice you have to change the constructor to be the right name. Now this is an exact copy. This is exactly the same thing we did before, which is we have to change for being a value task. But I want it to be an exact copy. I want to show you what's different. So here, instead of returning task, we're going to return value task, which changes how this works. So instead of returning this, and I'll actually just comment this out temporarily so you can see it, I'm going to say new value task of type list of person record and cache. So instead of saying task.fromResult, we're saying new value task of this type. That's the difference here. Okay, that's one, but then we have down here, load people. Well, that's the same thing. Let's copy this part of it right to here and say wrap this whole thing in a value task. So new value task, list of type person record, and load people. But notice this returns an async task. We're not changing that. That still works the same way. It's just we're saying that we're returning a value task from get people, let's say get people value task instead of get people task. So we are returning a value task instead of a task. And the benefit here is since most of the time we do this cache result, which is just going to be returning a synchronous value, not making anything asynchronous behind the scenes, then we're going to save a bunch of memory. So that's the only change we're going to make. And I know this is dense stuff, but I want to get you an example working, and we'll talk more about the high level of this now that you have an example to see. Okay, let's go back to the cache benchmark. And of course, we need to down here, actually up here first, let's say private value task example is value task example, if I spell it right. And then we're going to say value task example equals new time span from seconds and say 1. So we're doing the exact same thing here. And then down here for our value task example, we're going to say return await value task example. And again, we're going to say exclamation point to say, yes, we know it's not null, dot get people value task. So it's the exact same call, the exact same operation. We're just doing a value task instead of a task. Okay, so with all of that being done, it's a lot of setup work. It's a lot of task and async and all the rest. But once all this is done, what we end up with is let's run a benchmark. To do this, what we're going to do is actually open in File Explorer, and then I'm going to say open in terminal. So the reason for this is I prefer this terminal to the one built into Visual Studio. So I'm going to say .NET run -c in release. So this is going to run in release mode. Right now we're in debug mode normally, and we can just hit go. We want to run in release mode. We want to be disconnected from Visual Studio. I like this best. It's clean, it's simple, and it makes sure that we're not going to pollute our test with anything extra. CD value task explanation app. And I didn't spell it right. CD, CD value task explanation. That's why. There we go. So we were in the solution directory, not the project directory. The project directory is where the actual executable is, or the execution is run from. So we're going to run the project, not the solution. So we're going to run -c release from here. So this is going to compile our project in release mode. It's going to make sure that we're not doing anything extra. And then it's going to run a whole bunch of operations. Notice this number of operations we're running, that's in what, the 33 million operations, it looks like. So it's going to run a lot of these, and it's going to compare these two to each other. So yes, this is a lot of setup work and a lot of work. But let's talk briefly about what we're doing. We are, when we don't have to worry about the results coming back being mostly asynchronous, when the results coming back are probably going to be synchronous behind the scenes for an async call, and we're doing a lot of them, then a value task can give us extra performance, which means that we probably do not want to use value task except in very specific circumstances. So you might have watched the video at this point and go, wait, Tim, what you're saying is I almost never want to use this. And the answer is yes, you almost never want to use this. But you do want to know about it, because when it comes time to make your app more performant, this may be one of the areas where you address. You might say, this is the area that's going to be the area I can make some changes to make my app a little bit more performant, or a lot more performant, especially in terms of memory. So here we go. Here's the kind of the meat and potatoes results of all of this. Task example versus value task example. Now, the task example is a little slower than the value task example. That's because we're doing more asynchronous work here versus here, I believe. But really, it means we're just allocating a little bit more on the heap. Okay, so right here, Gen 0 allocated and the ratio. So we've allocated 144 bytes on average for this task example. So that's not a ton, 144 bytes, but that's compared to nothing, which means that we're saving that 144 bytes every time I make a call where it is a synchronous result, where the cache gets called. So if you're doing 1 million cache hits an hour, well, you're saving 1 million times 144 bytes. That could be a significant savings. However, if you're not, technically the value task is going to be a bit more memory intensive in the stack, and it's going to cause a couple other things where it's a little bit more expensive, because the upfront cost is a little bit more expensive, but over time cost is cheaper than the task example if you're mostly doing synchronous work. So again, probably the most, if I had to give you one, which is what I did, if I had to give you one example of where this might benefit you and where you might want to look first, is when you're talking to your cache. Because this is a very common pattern in software development, where you have a cache to make things more performant. So that way you're not talking to the database every single time you want a list of, let's say, the states in the US. Like you don't want to go to the database every time a person requests that, because that's silly. The number of states in the US doesn't change that often. So you want to make sure you go to the cache for that as much as possible. And that cache might live for days or weeks or even months. So therefore you have less and less actual asynchronous calls going to the database for that information, and more calls are going synchronously and just grabbing that cache information. That's where I would look for potential savings. But here's the deal. You really want to run some kind of benchmark on this. And this is where I, again, show you benchmark.net. I have a separate whole video on that. But you want to do a benchmark to make sure you're actually in the real world saving memory. Because this is not just one of those things where you guess. You try and figure out and make, look at the real world results of it. So in this benchmark, we're seeing that we're saving a little bit every single time we do a value task as compared to a task, but only in this specific type of circumstance. Normally, this is not a savings. We'd actually be increasing the amount of processing we do, and it'd be more expensive to run a value task. So let's talk about the other parts of a value task. Now, there's a lot more I can go into. I don't want to waste your time going too deep on this, but there are things you need to know about a value task. So let's close this out. Oh, by the way, we hit enter to finish it up. So it wasn't done until I hit enter. So now let's minimize this and let's talk about a task versus a value task. Let's go to our cache benchmark. So here I am returning an await. So I'm saying, hey, we're returning it. Now I could await this again. This method, I could await this again. And I could put the result of this task, this get people task, I could put this into, let's say, a win all, or I could put this into an array and keep track of these tasks. You don't want to do that with ValueTask. ValueTask, you want to treat it as a one-time return. So when you await it, that's it. You're done. You await it. If you want to go any further, you pass around the return value, not the value task. So you're not, when it comes to value tasks, you're not going to use when all or get results. You're not going to store it and reuse it. And you're not going to await it multiple times. So yes, there are some other limitations to it, but in the specific circumstances where you find that you need to do some optimization, ValueTask can be a great tool to pull off the shelf. So I figure it's important you know about it because it's one more tool in your toolbox, but I also want you to make sure you know this is not a common tool to use, and there are very limited circumstances where it is more valuable. But when you come across those circumstances, it can be really valuable. It can save a lot of memory pressure. It can reduce the amount of work your garbage collector is doing, and it can make your app overall more performant. You just have to use it in the right circumstances. Okay, so a bit more advanced topic today, but I figured I would cover this and kind of show you how this works and give you one more tool so that you're more prepared for more situations. All right, thanks for watching. And as always, I am Tim Corey.